Hello and welcome to today's section in further mathematics. Today we'll be talking on the topic friction. But before we go into friction, into the topic, let us have a brief preview of our previous lesson. Okay, thank you. Welcome back. Now, what happens when you rub your palms together? You experience some heat, and that heat is caused as a result of friction. Now, what is friction? Friction, when two bodies are in contact, each one is exerting a force on the other. Therefore, friction can be defined as a force which tends to oppose the relative motion of two surfaces in contact. Now, when you talk of friction, it can only take place in a rough surface. Friction cannot take place in ice, places as smooth as ice, places as flat and smooth as the glass. But it can only take place when the surface is rough. The direction of friction is opposite the direction in which the motion will occur. The frictional force, that is to say, if you project a ball, this is a ball. If you should kick this ball in this direction, there's a force that is acting in this direction that is trying to restrain the ball from moving forward. It is called a frictional force. It is always acting in the opposite direction of the applied force. You know, your applied force is in this direction. Now, the frictional force will apply in this other direction. So, when you talk about frictional force, it is directly proportional to the reaction, where R is the normal reaction between the bodies and obtained as R equals to mass times acceleration due to gravity. And U is the coefficient of friction, and the value depends only on the nature of the surface in contact. So if the nature of the surface have a zero coefficient of friction, then the frictional force at that point is zero. So let us do justice to this. We say a mass of 4 kilograms rests on a rough horizontal. If the word rough indicates the presence of friction, horizontal table, with U equals 0.4. Find the least force sufficient to move the mass. You have to look for the least force that is sufficient enough to move the mass to a certain direction. So with this, the sufficient force here is equal to R being equal to M times G, so which is equal to 4 times 10, which is 40, and F is equal to U R, so our F is equal to 0.4 times 40, so the value of our F is equal to 16 Newton. So the least force sufficient to move the mass is equal to 16 Newton. Now we can still move further. Now, if a force of 10 Newton is just sufficient to move a mass of 2 kilograms resting on a rough horizontal table, find the coefficient of friction. Now, at this point, we are not looking for force. You know, the formula says F equal to UR. Now, we have the force, we can generate R. Now, we are looking for coefficient of friction. So, let's make it the subject of the formula. Coefficient of friction is equal to friction all over normal reaction. So now from this, we can state clearly that the value of our F is equal to 10 Newton. But what is the value of R? R is equal to 2, which is the mass, times acceleration due to gravity, 10. So the value of our R is 20 Newton. So coefficient of friction will now be equal to 10 over 20, which is equal to 0.5, or you can still put it in fraction, half. So with this, I would like to say a very big thank you for being part of this lesson. Do well to attempt the question that will be coming up shortly, and don't also forget to always consult this platform when the need arises. Thank you, and see you in our next lesson.